Welcome to SS2 Computer Science, Term 3, Week 17. This lesson is dedicated to practicing WAEC-style past questions in computer science. WAEC Computer Science tests a broad range of topics from hardware and software fundamentals to programming, data structures, networking, databases, and emerging technologies. Working through past questions systematically is the most effective preparation for the actual examination. We will cover representative questions from multiple topic areas, model ideal answers, and discuss common student errors. Let us begin. Past questions Section 1, Hardware, Software, and Data Representation. Question 1, define the following as used in computer science. 1. Hardware, the physical, tangible components of a computer system, CPU, RAM, hard drive, monitor, keyboard, mouse, anything you can physically touch. 2. Software, programs and data that control and direct the hardware to perform tasks, intangible, stored in binary, examples, OS, word processor, games, browser. 3. Firmware, software that is permanently stored in ROM, read-only memory, provides basic instructions for hardware, BIOS/UEFI, basic input-output system. Question 1. Convert 10110011 binary to decimal. Method, multiply each bit by its positional value, powers of 2, 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2 plus 0 times 2 superscript 3 plus 0 times 2 superscript 2 plus 1 times 2 superscript 1 plus 1 times 2. Equals 128 plus 0 plus 32 plus 16 plus 0 plus 0 plus 2 plus 1 is equal to 179, decimal. Question 1, convert 245, decimal, to binary. Method, repeated division by 2, 245 divided by 2 is equal to 122 remainder 1, 122 divided by 2 is equal to 61 remainder 0, 61 divided by 2 is equal to 30 remainder 1, 30 divided by 2 is equal to 15 remainder 0, 15 divided by 2 is equal to 7 remainder 1, 7 divided by 2 is equal to 3 remainder 1, 3 divided by 2 is equal to 1 remainder 1, 1 divided by 2 is equal to 0 remainder 1, read remainders from bottom to top, 11110101. Question 1, perform binary addition. 1011 plus 1101, 1011 plus 1101, 1's column, 1 plus 1 is equal to 10, write 0 carry 1, 2's column, 1 plus 0 plus 1, carry, equals 10, write 0 carry 1, 4's column, 0 plus 1 plus 1, carry, equals 10, write 0 carry 1, 8's column, 1 plus 1 plus 1, carry, equals 11, write 11, result, 11,000 is equal to 24 decimal. Question 1, state 3 uses of secondary storage, store operating system and application software long-term, when power is off. Store user data files, documents, photos, videos, databases. Backup and archive data. Transfer data between computers, USB drives. Past question Section 2, Programming and Algorithms. Question 2, write an algorithm, pseudocode, to find the largest of three numbers A, B, and C. Begin, input A, B, C. If A greater than B and A greater than C, then largest equals A, else if B greater than A and B greater than C, then largest equals B, else largest equals C, and if output the largest is plus largest, END. Question 2, trace the following pseudocode and state the output, x equals 5, y equals 3, while x greater than 0, y equals y plus x equals x, 2, and while, output y, trace, x equals 5, y equals 3, iteration 1, x equals 5, 0, y equals 3 plus 5 equals 8, x equals 5 dash 2 equals 3, iteration 2, x equals 3, 0, y equals 8 plus 3 equals 11, x equals 3 dash 2 equals 1, iteration 3, x equals 1, 0, y equals 11 plus 1 equals 12, x equals 1 dash 2 equals dash 1, iteration 4, x equals dash 1, minus 1 greater than 0 is false loop ends, output, 12. Question 2. C. Explain the difference between a compiler and an interpreter. Compiler translates the entire source code into machine code at once before execution, produces an executable file. Once compiled, runs fast, no translation overhead at runtime, errors reported all at once. Examples: C, C++, Java, or to bytecode. Interpreter translates and executes source code line by line, no separate executable produced, slower, translates each time it runs, shows the first error then stops, easier for debugging interactively. Examples: Python, JavaScript, traditionally. Question 2. State 2 advantages of high-level languages over machine code/assembly. Easier to write and understand, uses English-like syntax, portable, can run on different computer architectures. Machine code is CPU-specific, faster development time, easier to maintain, built-in functions and libraries reduce code length. Past question section 3, networking and databases. Question 3, distinguish between LAN and WAN. LAN, local area network, covers a small geographical area, one building, one office, one school campus, owned and managed by a single organization, high speed, 1 gigabit per second or more, low cost. Example: school computer lab network. 1. Wide area network covers a large geographical area, cities, countries, continents, uses public infrastructure, telephone lines, optical fiber, satellite, lower speed than LAN typically. Example: the Internet, Nigeria's NECO national network. Question 3. State the functions of the following network devices. Hub, broadcast data packets received on one port to all other ports, operates at OSI layer 1, creates collision domain, mostly obsolete, replaced by switches. Switch, forwards data packets only to the specific port connected to the destination device, uses MAC addresses, operates at layer 2, more efficient than hub, the standard device in modern LANs. Router, connects different networks together, e.g. LAN to the Internet, determines the best path for data packets, operates at layer 3, IP addresses. Every home broadband modem contains a router. Question 3. C. Explain the client-server model. Client-server, network architecture where clients, user computers/devices, request services from servers, powerful computers that provide services. The server hosts resources, websites, databases, email, files. Clients access those resources over the network. Examples: web browser, client, request a web page from a web server. Email client requests emails from a mail server. Question 3. Define primary key and foreign key in a database. Primary key, a column, or combination, that uniquely identifies each row in a table, must be unique, must not be null. Foreign key, a column in one table that references the primary key of another table, establishes relationships between tables, ensures referential integrity. Past question section 4, data structures, OOP, and security. Question 4, explain the difference between a stack and a queue with examples. Stack, LIFO, last in, first out, last element added is first removed. Operations, push, add to top, pop, remove from top. Example: function call stack, last function called is the first to return. Undo function in word processors. Queue, FIFO, or first in, first out, first element added is first removed. Operations, enqueue, add to rear, dequeue, remove from front. Example: print queue, first document sent to printer is printed first. Customer service line. Question 4. State the 4 principles of object-oriented programming: encapsulation, bundling data, attributes, and methods that operate on that data inside a class, hiding internal implementation details. Inheritance, child class inherits attributes and methods from parent class, promotes code reuse, models ISA relationships. Polymorphism, same method name works differently for different classes, achieved through method overriding, flexible code. Abstraction, hiding complex implementation, showing only essential features, simplifies usage of complex systems. Question 4. C. Define the following security terms. SQL injection, an attack where malicious SQL code is inserted into an input field to manipulate database queries, prevented by parameterized queries. Firewall, a network security device that monitors and controls network traffic based on rules, blocks unauthorized access. VPN, virtual private network, creates an encrypted tunnel over the internet for secure, private communication, hides users' IP address and location. Phishing, a social engineering attack using fraudulent emails or websites to trick users into revealing passwords or personal information. Question 4. State the time complexity of the following operations: linear search, O, n, binary search, O, log n, bubble sort, worst case, O, n superscript 2, merge sort, all cases, O, n log n, accessing an array element by index, O, 1. WAEC Computer Science Examination Structure and Tips, Paper 1, Objectives, Multiple Choice 50 questions, 1 mark each, 1 hour, no negative marking, read all options carefully, eliminate wrong choices, mark and return to uncertain questions. Paper 2, Theory, short answer and essay, usually 2 to 3 sections, select required number of questions, approximately 2.5 to 3 hours. Common errors to avoid in WAEC Computer Science: binary conversion, always show working, write remainders from bottom to top, double check by converting back. Algorithm tracing, trace step by step, track each variable's value at each step, do not skip iterations. Stack/queue operations, know which end to add, remove from, top for stack, front for dequeue, rear for enqueue. OOP definitions, state all 4 principles in order, use precise terms. Network device functions, distinguish hub, broadcast to all, switch, selective delivery, router, connects different networks. Database, always define primary key and foreign key correctly with examples. Data representation, remember ASCII, binary, hexadecimal, be able to convert between them. Key topics for WAEC Computer Science revision: number systems, binary, octal, hexadecimal, decimal, conversions, hardware and software, networks, LAN, WAN, protocols, OSI model, database, SQL, normalization, primary/foreign keys, programming, pseudocode, flowcharts, Python basics, data structures, stack, queue, linked list, arrays, OOP, 4 principles, classes, objects, algorithms, sorting, searching, BIGO, cybersecurity, firewall, VPN, SQL injection, XSS, operating systems, process management, scheduling, cloud computing and IaaS, PaaS, SaaS, AI and machine learning, basic concept.